Professor, thank you so much for joining us today. First of all, tell us a little bit about the zinc oxide project.
The zinc oxide project is one where we're looking at improving the efficiency of the light emission properties of that material. And this follows on from work that we've previously done on a material known as gallium nitride. And that work started 10 years ago and now has gone completely through from having an idea about how to use this material as an efficient light emitting material all the way through now, so it's a commercial product. And this is something that you'll see that's been implemented in a whole range of applications. It's sort of a silent revolution. So your standard incandescent bulb that's been around for the past 100 years will become a thing of the past in the next 10 years or so.
Okay, so just explain to me a little bit more about why it is so important.
Well, in terms of lighting, and this is known as solid state lighting, so this is a device known as a diode, and a diode consists of a positive and a negative, or positive and negative areas. And with this material, because of these positive and negative areas, it sets up a little voltage barrier. And this voltage barrier, if we apply a voltage to it, it can overcome, the electrons can overcome this barrier, and that interaction will produce light. Now the advantage is it does this without producing any heat. So it's a very efficient process compared with, say, an incandescent bulb, where 90% of the energy that's used is lost as heat rather than light. So it's a very low power for a very high brightness.
So how exactly would this be used in people's everyday lives?
Well, it's already now these light emitting diode traffic lights have proliferated around the city already. If you go to any of the traffic lights now, you'll basically see that instead of one bulb, it's actually comprised of something like 140 LEDs. Now the advantage with this, even though there's 140 of these, because of their low power consumption, that light assembly actually uses 1/3 less power than a conventional incandescent bulb. Even, for example, these torches or flashlights that we have here, you can see that the incandescent bulbs have been replaced with the LED devices here. The advantage here is this bulb lasts for 10 years, so it has a very long lifetime. And this is the same sort of technology that will be slowly introduced into domestic lighting. Actually, lighting consumes something of the order of 20% of the total power worldwide. So if we can introduce solid state lighting where we're actually using at least a half, you can see immediately that we have a 10% drop in our power usage, which translates to a 10% drop in the production of greenhouse gases.
And how does this apply with your research then?
Well, with our work, we work at a very fundamental level, understanding how we can improve the efficiency of this material by growing this material with better quality. This material is all man-made material, so it's grown atom by atom, layer by layer. And as part of this process has been continuously refined to make better and better quality materials. And so we study the light emission from areas that are 1/millionth of a millimetre to get a complete understanding of the mechanisms that are involved in producing the light emission.
So I imagine that means you have some pretty spectacular machinery?
Yes, like the one behind me here. This enables us to accelerate electrons to very high speed and inject them into one of these materials, these new advanced materials, into this very small volume, and then study how the light is emitted by the various attachments that are sitting on the microscope behind me.
Okay, so let's put that in everyday terms. How long before we see results outside the lab?
Well, as I said, in terms of the gallium nitride technology that we've been working on for 10 years, that's already there. I mean, that's out there. These are now engineering issues to make the product more cost efficient. What we're now working on is a material known as zinc oxide, And zinc oxide has excellent properties, in some sense much better properties than gallium nitride. And this is sort of the thrust of our research, is trying to understand the optical and electrical properties of zinc oxide. So.
Excellent. And can you give me a time frame, a ballpark time frame?
Well, we're not the only group working on this. There's a lot of groups around the world that are working on this problem. And as this technology improves and we can produce more efficient bulbs that use less power and emit more light, and also as the cost and the scale of production increases, the cost of these will continue to fall. So it's very possible that in the next, well, certainly in the next 20 years, that there'll be no incandescent sources in use at all.
Professor, thank you so much for your time and taking
my
the time
pleasure.
to explain some very complex ideas.
Thank you.
Best of luck with your research.
Thank you very much.